gravity well, black hole, event horizon, the singularity, and how we observe black holes. So all objects in the universe that have mass change space and time around them. So the Earth is pulling space and time downward into a little dip that can be observed, because what do we see? We see satellites going around the Earth. It's my horrible satellite. And they sit in this gravity well. They continue going around and they orbit because they have some sort of velocity. And this well that is here, this dip in space, is a gravity well. That's how we refer to it, because the gravity is bending space and time and forming a kind of well-like structure. Now, the more mass you have in space, the deeper this gravity well can be. So if you get a deeper gravity well, that means that the walls, there's not really walls that you can see, are steeper than if you had a gravity well with less mass. In fact, if I have small objects so if I have two very small objects, and one has 10 times the mass, I am going to get a much steeper gravity well on the object with 10 times the mass, and a much shallower gravity well for objects the same size, simply because the more matter in a given space is going to bend space and time around it, creating a deeper gravity well. So we have a large star that's dying, and here's its core. When a large star dies, it explodes in a massive supernova. And every so often, we get a very massive star, that the compression waves that come back in here, they compress the core. And they compress the core into a form of matter that the universe really doesn't want to exist because it's too much matter in a single spot. So this core is compressed down to what we think of as a single point in space, a single dot in space, if you will. And so you have an incredible amount of mass from the core that causes a gravity well that is so steep that light, when it gets past a certain point on that gravity well, light gets caught and just keeps going down, because even light is not fast enough to escape this incredibly steep gravity well. And that is a black hole. It's called a black hole because it doesn't act like a vacuum. It's just that when objects cross a certain point on the black hole, either they are flung out at tremendous velocity, or they cross this point, and since nothing travels any faster than that, they're gone, and we don't see them ever again. There's a couple of structures on a black hole that you need to be aware of. Here's our big gravity well. One will represent by this dotted line, and the other will just represent it by that tiny little green dot that is off the screen. So let's change that. We're going to zoom down a little bit. There. Now we can see it all. Now what the yellow dotted line is, this is the event horizon. This is where the gravity well becomes strong enough that light can escape on the outside, but once it gets on the inside, it cannot travel fast enough to get out. So the event horizon is the point of no return. This is a point of no return. Da, 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 da. Yes, I don't know that song very well, but it did just pop in my head possibly into yours. And this single green dot right here, the single green dot is where all the mass is for the black hole. And that is the singularity. The singularity, where all the matter is at for a black hole in space. Now, we cannot directly observe black holes. What we can see is what they do to things around them. Now, the top up here, this is an artist's impression of what's happening around this black hole. What we actually observe is we observe that something is sucking matter off of a large star, and I'm not really sure why the X-ray image doesn't really show anything on this slide, but it's sucking some energy, and the X-rays are being released in some sort of burst, which we can measure. And so what we think is happening around this Chandra star is that there's a black hole somewhere over here, and that black hole is gravitationally pulling matter into itself as that matter slowly spirals down the black hole's gravity well. Now, gravity wells are neat because we think that there's a huge black hole at the center of the Milky Way. This is a mathematical representation done by UCLA of all of these stars at the center of our galaxy. And these stars are moving at hypervelocities. They are moving at extremely fast velocities. And we notice that they all appear to go around a single point in space where there is no star, but something is there that has millions and millions times the mass of our sun. So black holes, that's another evidence for that there's an evidence for a black hole at the center of the Milky Way. So the center of our galaxy. There's evidence that there's a very large black hole in existence at the center of our galaxy because of how fast these stars are moving as they approach the black hole and then kind of go skip out of the black hole's gravity well. Thank you for watching. This has been Justin Higgins. Have a glorious day and be excellent to each other.